This is Josh White with JW Math Tutoring, and today's video is going to cover 40 formulas that you need to know in order to do well on the math section of the ACT. Most of these formulas you should have memorized by the time you go take the test, but at a minimum you should be familiar with them and know how to use them, which is what I'm going to show and demonstrate in this video. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Alright, two quick things just before we get started. First, if you like the content that I produce on my channel, SAT prep, ACT prep, or general math content, please do click the thumbs up on this video and also subscribe to my channel and sign up for notifications as well. That way you'll find out right away whenever I post a new math related video. Second thing, if you're looking to improve your ACT math score, then please do check out my Improve Your ACT Math Score course. It's currently live on both Teachable and Udemy. It covers techniques such as back solving, picking numbers, process of elimination. It shows you how to use the graphing calculator to solve problems entirely from start to finish on the ACT, and it also reviews the common topics in algebra, geometry, probability and statistics, and some other random topics as well. Alright, so with that being said, basically what I'm just going to do in this video is go through and highlight, talk about briefly 40, or could even really actually be more depending on how you count, math formulas that you need to know and be familiar with in order to do well on the math section of the ACT. So basically what I'm going to do is just kind of point out the formula, highlight the formula, talk about what it's used for, what types of problems you might be on the lookout for, and then just move on to the next one. All right. So first thing I want to talk about at the very top here is formula for the slope of a line. So obviously, if you have 2 points and you're trying to find the slope between them, you just plug them into the slope formula. Y2 minus y1 over x2 minus x1, or rise over run. Very common problem that comes up where you're given 2 points and you need to find the slope between them, or you might be given an equation of a line in graph form, meaning the line's graphed out, and you might need to calculate the slope. Another thing that you might need to calculate if you're given 2 points is the distance between them, and you can see on the screen here we have the distance formula. So just basically plugging in the values, you're just really subtracting them and then squaring those numbers, adding those results, and then square rooting the whole thing. It's really just a modified version, to be honest with you, of Pythagorean theorem, which we'll get to in a little bit. All right. Then below that we have the midpoint formula. So this is used if you either A, have 2 points and you want to find the coordinates of the midpoint between them. You just basically average the x values and average the y values, add them together, divide by 2. Or technically you could also use it if you have 1 point and you have the midpoint value, and then you want to solve for what the other point is. Although a lot of times it's easier to graph it out and count. So what I mean by that is, let's say you have 1 point on the line as being 1, 3, and let's say you're told that the midpoint is 4, 6. Okay, so this is the midpoint, this is point A. We want to find out what point B is, right? So you could still use these formulas. You would just set, the x value equal to, the x coordinate from the first point plus, whatever, x2 divided by 2. And then you could do the same with the y's, where you take the y coordinate from the midpoint, set that equal to the y coordinate from the first point, obviously add to the second one, and then just divide by 2. Okay, and go ahead and solve it from there. All right. Next, forms of equations of lines. So you have slope-intercept form, y equals mx plus b, m is your slope, b is your y-intercept. Again, very common topic, comes up on multiple questions, so be sure to know that and be familiar with that. Also, standard form, you do see sometimes, and things to know about standard form are that the form, if the slope is over here on the right, it's just negative a over b, so it's the coefficient in front of the x, divided by the coefficient in front of the y, and you take the opposite of that. And this is not that common, but technically your y-intercept is going to be the point 0, comma, c divided by b. Okay, so just make sure that you're familiar with all those. A couple other things just to be aware of with regards to lines. Horizontal lines are always y equals a number. They have a slope of 0. Your vertical lines are x equals a number, and the slope of a vertical line will always be undefined. The slope does not exist because your run is technically 0 and you're trying to divide by 0. Also, not really a formula, so to speak, but parallel lines are two lines that have the same slope, and perpendicular lines are slopes which are opposite reciprocals. So examples would be like 1/3 and -3, or maybe -2/3 and +3/2. Okay, so those are the most of the formulas related to lines. Let's now start taking a look at some things related to triangles. So obviously, you should be familiar with the Pythagorean theorem, a squared plus b squared equals c squared. I mentioned this earlier, that the distance formula is just technically a rearranged version of this if you actually took the coordinates of all three vertices, from a triangle here. Okay. So now, special right triangles. So the 30, 60, 90 and the 45, 45, 90. So the formulas, or the things you need to know or be aware of, is that in a 30, 60, 90, if you're going from the short leg to the long leg, you multiply by square root of 3. That's basically what this first formula right here says. It says, longer leg equals shorter leg times root 3. Or if you're going from the short leg to the hypotenuse, it is times 2. That's this formula right here. Hypotenuse equals shorter leg times 2. Now, if you're going in reverse, i.e. you're starting at the hypotenuse and going to the short leg, or you're starting at the longer leg, which is the one across from the 60, and going to the shorter leg, then you would end up dividing by those same factors. So the shorter leg is equal to the longer leg divided by square root 3, or it's also equal to the hypotenuse divided by square root of 2. Not square root of 2, hypotenuse divided by 2. Hypotenuse basically cut in half. And now, for the one next to it, when you have a 45, 45, 90 right triangle, basically an isosceles right triangle, so to get from the legs, since they're each the same, to the hypotenuse, you just multiply by square root of 2. That's the first formula here. Hypotenuse equals leg times root 2. And if you want to go in reverse, obviously you would just divide by that same factor. So you would take the hypotenuse, you would divide it by square root of 2, and that would give you the value for each leg of your 45, 45, 90 triangle. Now, one other formula to be aware of with regards to triangles is 1/2 times base times height. And in this formula, you have your base and your height, where the height is basically the perpendicular distance from the opposite vertex to your base. All right, now continuing to take a look at some formulas related to circles. So the first one is, check that off. The first one is the standard form equation for a circle here, x minus h quantity squared plus y minus k quantity squared equals r squared. Your center here is just h comma k. Your radius is r. So just make sure whatever number you see in the equation on the right side, you square root that in order to get your radius. So if you see 9, that means the radius is 3. If you see 25, that means the radius is 5. Also, we have here formulas for the circumference and area of a circle. Circumference also is equal to pi times the diameter, but the more common way you see it is 2 pi times the radius. Of course, circumference is total distance around, a circle, around the outside of it. If you walked or ran around the outside of a circle. Area is the total, basically amount of shading you would get inside the area, inside the circle itself if you filled it all in. Now the next two, length of an arc and area of a sector. So this is basically if you had a circle and you cut out a segment of it, like a piece of pizza, slice of pizza. Basically, the length of the arc is like, how long it is just for this part right here around the outside. And all you're really doing is you're taking the circumference, which is the 2 pi r, and you're multiplying that by the measure of the central angle in here, which I just labeled n, and then divided by 360. So whatever this angle inside is, you put that over 360, and then you multiply that by the circumference, and that tells you how long this little arc is. And the same thing is done with the area of a sector. Basically, you find the overall area of the circle, which is pi r squared, and then we multiply that by a fraction, and that fraction is just this central angle divided by 360. So if the angle in the middle is whatever, 75, you divide 75 by 360, then multiply that by pi r squared. Now, another kind of good formula to be aware of, be familiar with, are the powers of I. So, I is defined to be equal to the square root of -1. It's used to make imaginary and complex numbers whenever you get a negative number under a radical, specifically a square root. So the things to be aware of are that I squared is equal to -1, I to the third is equal to -I, and I to the fourth is equal to 1. These could come into play on problems where you have complex number operations, or you could also have a problem where you have to simplify something like, whatever, I to the 281st power, to figure out what it's actually equal to. All right, now at the bottom we have another very common math formula that you should be aware of, which is the quadratic formula. So this can be used to solve any quadratic equation. Just keep in mind that before you use it, you need to make sure that the equation is equal to 0, and then you can plug in a, b, and c and simplify as needed. And again, this can solve any quadratic equation, unlike factoring, which can only solve sum. Now, moving on to the next page, here we have some geometric, kind of shapes, 2D shapes, and then below that 3D figures. So first, we have just a basic rectangle, or you could also make a square out of it if the length and width are the same. But for basic rectangle, the area is just length times width. Common thing to know. And its perimeter is just 2 times the length plus 2 times the width. Next to that, we have a parallelogram. So parallelogram is when you have the basically the opposite sides are parallel, but of course the angles are not necessarily right angles like they are in a rectangle or a square. So it's kind of like, you take a rectangle and you kind of slant it a little bit. Its area is equal to the base times the height. And again, here, the base is typically one of the sides, and the height is the perpendicular distance from the other side. So you do not multiply the base times like the other side length. In other words, it's not base times width. It is technically the base times the height as pictured here. Then you also have trapezoids that come into play sometimes. So for a trapezoid, the most common formula you see is dealing with the area of it, and that's just going to be equal to basically it's the average of the bases times the height, or in other words, as you see here, it's base 1 plus base 2 divided by 2, and then that whole thing times the height. You can also sometimes see it written as well as like 1/2 and then base 1 plus base 2 inside here times the height. So it's just a different way of writing it, but it means the same thing. You get the same answer. And of course, your bases are your two parallel sides. The height is the perpendicular distance between those parallel sides. So the height is basically the same thing as it is for a parallelogram. Okay. Then we have some solid figures. So if you have what I call, a rectangular solid or a rectangular prism here, basically like, take a rectangle and then give it, like a third dimension, so to speak. So its volume is just its length times width times height, just all three dimensions multiplied together. And the surface area is just going to be like 2 times the length times the width plus 2 times the height times the width plus 2 times the length times the height. Basically, there are three pairs of sides that each have the same area, so that's why there's a 2 in front of each of them. It's like front and back, left and right, top and bottom. Like those areas are all the same, so you just double it for each of them. And you can also see this one written as like 2 times and then LW plus HW plus LH. Just sometimes you'll see it written with the 2 out front and all the terms inside here, but again, get the same answer regardless of which format it's in. Okay, next, if you have a cylinder, so the volume of a cylinder is just pi r squared h. It's basically like, if you took a circle and then you extended it into a third dimension, that's where the height comes from. So you just take the area of the circle, pi r squared, multiply it by h. And the surface area of a like a right cylinder, as compared to say a slanted cylinder, which you don't see generally, is going to be made up of two parts. You have 2 pi r squared h, and then you also have 2 pi r squared. So the 2 pi r squared part at the back, that's technically the top and bottom. That's the area of the top circle and the bottom circle. And then the 2 pi r squared h is like this middle part in here. It's like if you kind of unwrapped that entire thing, it technically, would make a rectangle. And one side would be the height of h, and the other side would have a length of 2 pi r squared. So you multiply those together, and then add those two separate parts to get the surface area, of a cylinder. Now, another thing that has been on some tests previously but does not come up very frequently is the number of diagonals in a regular polygon with n sides. So when we're talking about diagonals, just to show you an example here, if we have a pentagon, diagonals go from, one vertex to a non-adjacent vertex. So for example, from here to here would be diagonal, and from here to here would be diagonal. Anything else you draw from this vertex right here, it would either, like if you go up here, it would make a side. If you go down here, it would make a side. So you can see the formula there. It's n minus 3, where n is the number of sides, times n divided by 2. So you just plug it into that formula. Or if you're familiar with probability statistics like combinations, and this can just be done on the calculator, it also just works out to NCR minus n. So you can just plug that into your calculator, and then basically the r is just going to equal 2 because every diagonal is going to have 2 points in it, a starting point and ending point. And n, of course, is your number of sides. So like in this example with the pentagon, it would be 5c2 minus 5. And that should give us the same value as 5 minus 3 times 5 divided by 2. All right, moving on now to look at some trig-related formulas. So first we have the basic ones for the three basic trig functions: sine, cosine, and tangent. For obviously, SOHCAHTOA is the common acronym you have probably heard before, where the O stands for opposite, side opposite the angle, H stands for the hypotenuse of your right triangle, and A stands for the side which is adjacent to the angle you're looking at. So the sine is the opposite over hypotenuse. You have cosine, which is the adjacent over the hypotenuse. And you have the tangent, which is the opposite over the adjacent. And you can see the examples, from this triangle over here. So again, main thing to be aware of is just how to set these all up. And again, the common acronym SOHCAHTOA, is very helpful and useful with that. Next, I have two more advanced formulas. Generally, on law of cosines problems, the formula is given. On law of sines problems, the formula is not always given. So the law of sines here, the capital letters represent angles in your triangle, A, B, and C, and the lowercase letters represent the sides that are across from those angles, lowercase a, b, and c. So a couple things to be aware of. Law of sines and law of cosines can be used on any triangle as compared to the trig functions up here, which are only for right triangles. So that's one thing to be aware of. Second of all, law of sines technically can also be written with the sides on top. So you could also write it with, the c on top and the sine c on the bottom, and the b on top and the sine b on the bottom, and the lowercase a on top and sine a on the bottom. So these two versions of the formula right here are equivalent to each other. You can use whichever one you want. Now, the way you use this is basically you pick any two of these expressions of these fractions and you set them equal and make a proportion based on what you're given in the problem. So maybe it's like you pick these two and you plug in for like sine A and maybe angle A, angle B, and side B, and you plug those in and then solve for side A. Or instead, maybe you pick, these two because three of the four things and whatever. Okay, but the point is you only use two of them at the same time. Now, for the law of cosines, again, these formulas are usually given on the problems where you're required to use them. Not always, though. But the thing is, when you look at these formulas here, they're very, very similar. Essentially, it's really just the same formula. Essentially, the angle on, or excuse me, the side or the variable on the left side is the side that is across from, the angle either that you're solving for if you are given three sides, or it's the side across from the angle that you know. So if you know one angle, whether it's A, B, or C, like that angle measurement is going in, on the right side here that you're taking the cosine of, and then the side across from that is what will be on the other side by itself. And then the other two letters are the two other sides not related to the angle you are solving for or the angle that you know the value of. But they're all really saying, essentially the same thing. Now, last two formulas deal with probability and statistics. So the first one, which would be pretty common, is when you're going to find the average of something or the mean, you just add up all your items to get what their total is, and then you divide by the number of items. So you have 5 scores for something, you add them all up, and you divide by 5. But the key thing to be familiar with is this rearranged version of it right here. If you instead multiply the average by the number of items you have, that will tell you how much all the items have to add up to. Even if you don't know the individual values, you can still figure out how much in total all the items equal. So that is an important formula, important property to remember, because that comes into play a lot on questions that you see on the ACT. And then the last one down here that I have on the sheet is expected value. So this is basically when you have problems that you're trying to calculate the expected value of something. Normally, the values would be given in a table, and you would be given, the probability of first of all, you'd be given values, whether they're dollars or whatever they are, and then you would be given probabilities that correspond to them. I mean, some problems are more advanced and you might have to figure out the probability for each, but once you have the probabilities, then basically what it says is you just multiply the probability of the event times the actual outcome. So you just either go down the chart or you make a list of okay, the probability, whatever, of this happening is 1/2, and the value associated with it is whatever, $2. And then the probability of this happening is 1/4, and the value associated with it is, I don't know, $5. And the probability of this happening is 1/4, and the value associated with it is $10. And then you just multiply all those out. You add up everything, and then whatever number you get as your final answer, that is the expected value for the situation. Okay, so those were 40, or I think actually more, formulas that you need to know in order to do well on the math section of the ACT. So if you're studying for the ACT and you have not basically started reviewing these formulas or memorizing them, looking over them, I mean, you definitely want to do that as far as possible so that you get familiar with them, and just basically commit them to memory. This sheet that I've gone through, which has all the formulas on it, this will be available, just a link in the description that you can download and use and practice with and memorize. Otherwise, thanks for checking out this video. If you have any questions or comments, please do leave them below. And if there's other ACT or SAT math content you are interested in, please, again, get in contact with me either by leaving a comment on this video, or you can also send me an email as well.